Children, now let us move on to the next question from our JEE Mains paper, which was held in the year 2023, right? Evening session paper. So that is question number 13. So what I ask you is that take a pause, read the question at least 2 to 3 times. You will understand better what I am explaining. Okay? Now, it was clearly mentioned that it is nothing but a cell. So whenever a cell like that you hear, so it may be from two different chapters, either from electromagnetic induction or either from current electricity. So first thing you have to be very clear. Next is saying that two resistors each of 100 ohms and they are in series. So undoubtedly this is from current electricity topic, right? So now this question I say that it is from current electricity chapter. In current electricity chapter, it is from subtopic cells. And it's EMF like this. Okay. So now I want to draw the diagram. So there is a series combination of two resistors. So let me draw that like this. There is a series combination of two resistors, each of 100 ohms. Now a cell of EMF 90 volt is connected across this. So this is the way we have to show. So to this series combination, there is a cell of EMF 90 volt. Okay. Now a voltmeter is used to measure the potential difference across each resistor. He is asking the reading of the voltmeter. Okay, voltmeter, how it is connected in series or parallel? So no doubt it must be in parallel. So here I am taking an voltmeter V. I am taking an voltmeter V. Like this. Whose internal resistance is 400 ohms. So generally in ideal voltmeter, you will never have this. But we cannot get ideal voltmeter, no. So practically there will be some small amount of internal resistance. Like this. Okay. So first we are having this total voltage or total EMF and we are having two resistance R1 and R2 like this. Now this is the battery internal resistance. Okay. Now let us find out the total resistance in the circuit. So look carefully, my dear children. Here this 100 ohms and voltmeter internal resistance, this part, you have to look carefully. These two are connected in parallel. So what is the formula? So if there are two resistance in parallel, what is the formula? R1 into R2 by R1 plus R2. So let me write here. Resistance P stands for parallel. So the formula for this is R1 into R2 by R1 plus R2. This is what the formula for two resistance in parallel. So here R1 is nothing but 100 and R2 is nothing but 400. Sum of those two will give you 500. So these two is cancelled here. So 587. So total resistance in parallel is 80 ohms. But once again let me draw the circuit so that you will understand better. So getting like this. So this is of 80 ohms. In addition to this there is one more resistance here which is of 100 ohms. Now this combination is connected in parallel. Okay. This combination is connected to a cell of EMF which is equal to 90 volt. The symbol for EMF is E. So why don't you apply Ohm's law for this? Whenever you know the voltage as well as the resistance, how to find the current? I equal to V by R. So now you are having these two resistances in series. So now the total equivalent resistance is 80 plus 100 which is equal to 180. So as per Ohm's law, how to find out the current? I equal to V by R. So where V is 90, I can write this as E or V, no problem, okay. So 90 by 180, so which is equal to 1 by 2. So the current flowing in the circuit is 1 by 2 amps, half of 0.5 or you could say 1 by 2, that's your wish. So here the total current which is coming out from the battery positive terminal is 1 by 2, is 1 by 2 here. Let me write like this so that you will understand better. Now let us go back into the circuit. So here the current flowing in the circuit right now it is 1 by 2 amps, okay. Now let us go back to the previous circuit. Once again, you will understand in depth, my dear. So here the total current that is coming out from the battery is 1 by 2 amperes. 1 by 2. So whatever the arrow I am putting here, it indicates the current is 1 by 2 amps. Now at this junction, so current is splitting. At this junction, current is splitting. How? So like this. Some part of the current is flowing through voltmeter and voltmeter internal resistance and remaining part it is moving through this 100 ohms resistance like this. So two things. So let me draw this again, okay? Only the small part I will draw. Voltmeter with its internal resistance. Nobody will show you internal resistance because it is not required to show. But still, I am drawing so that I feel that you will understand better. Now the current that is entering here, it is half amperes, 1 by 2. So here this resistance is 100 ohms, whereas this resistance is 400. I hope you know the current division formula. So as per current division rule, what we know is that if you want to find out the current through the first resistance which is in parallel, you have to use the formula I1 is equal to total current I into other resistance that was in parallel divided by sum of these resistances. This is what the formula we have studied. So here in place of I1, I write that current flowing through 100 ohms, which is equal to total current that is entering, that is half 120 amperes, multiplied by other resistance in parallel. So here other resistance is nothing but 400. Sum of those two resistances, one is 100 and other one is 400. Now let me substitute this. In place of I, the total current is half. In place of R suffix 400, it is just 400 only. And 100 plus 400 like this. So now I am going to find out the current flowing through 100 ohms resistance. So what I get here is that half into 400 by 500. This cancel, okay? This also cancel. So the current that is flowing through 100 ohms is 2 by 5 amperes. The current that is flowing through 100 ohms is 2 by 5 amperes. Why I am interested to find out the current flowing through 100 ohms? That is what the question. See, here voltmeter is connected across 100 ohms. So what are the voltage that is present across the 100 ohms? The same voltage is reflected back in voltmeter, isn't it? Because in parallel the voltage is same and the voltmeter is measuring voltage across 100 ohms. That is the reason I am trying to find out the voltage across 100 ohms by knowing the current flowing through 100 ohms. Understand? So I will write that voltmeter reading is nothing but voltage across 100 ohms. As per Ohm's law, V equal to IR. So voltage across 100 ohms is nothing but current flowing through 100 ohms into resistance, that is 100 only. So here the current flowing through 100 ohms is 2 by 5 into 100. So by solving this, 520 is 100. So by solving this, I will get it as 40 amperes. So now by solving this, I will get it as 40 volts. So now the voltmeter reading is nothing but 40 volts. Now let us check the options. So the first option itself is 40 volts. First option itself is 40 volts. Hence, so what is the answer for this particular question? Option 1. Option 1 is correct, isn't it? So I am sure that each and every one of you understood this. So now let us move on to the next one.